Hey guys, so today we're going to do a video about how to solve limits at infinity. This means we have a limit as x approaches positive or negative infinity. If you want a video about how to solve limits when x approaches some number, I have other videos for that. And so today we're going to focus on plus and minus infinity of polynomial functions and rational functions. And what polynomials are is they're just your typical quadratic, cubic, just stuff like that. Notice that there's no denominator for your polynomials. Then your rational, I like to call them like fraction functions, because you usually have a polynomial divided by another polynomial, like we do in this example here. And then there's three rules for rational limits that we have right here, and we'll go through all of them. Notice that every single one, it depends on the degrees of the numerator and the denominator, and only the highest degree. That'll be a trend in limits. Get in the habit of noticing the highest degree. Alright, so let's just get started. Let's just start with regular polynomials. Now here is a big hint. All polynomials, infinite limits, will be either positive infinity or negative infinity. Limit as x approaches positive and negative infinity, f of x will equal positive and negative, positive or negative I should say, infinity. And the way to figure it out is, again, we have to do that thing that we were talking about earlier, where we're going to notice the highest degree, which in this case I say, well, 3 is the highest degree, and we're going to look at just that term. So what we can do is we can say limit as x approaches infinity. We know our important term is the 3x cubed. And really what we can do is we can discount completely the 2x squared minus 7. That just doesn't matter. And the reason is, if this helps you visualize it, is when you take a huge number and you cube it, it is so much greater than if you take that number and you square it, that this number becomes obsolete. So it's kind of like when you take 1,000, like plus 1, that 1 doesn't really do much, but now you're talking about that on a much, much larger scale. So yeah, it just doesn't matter because it's infinity. And then what we do is we plug in the infinity for the x. So then we get limit as x approaches infinity is going to be 3 times infinity cubed. And if infinity, just think of it as some big, big number, you can tell it's just going to keep getting bigger forever and ever. It's never going to go negative, so the answer is just positive infinity. Look at your two answer choices. You had plus or minus infinity. For this one, it was positive infinity. And now let's take a look as if we have the same polynomial, but now we're looking to see what it approaches as x approaches negative infinity. So we've still got 3x cubed plus 2x squared minus 7. These same exact rules apply. Again, we only care about the largest degree term, so we're going to cross out the 2x squared minus 7. And now we can kind of substitute infinity and see what would happen. So we have limit as x approaches negative infinity. 3 times, it'd be negative infinity cubed. And we need to figure out what that would equal. Well, if you take, I just like to imagine infinity as just some big negative number. If I take some big negative number and cube it, it's going to be negative. So what that's doing is it's still just going to approach negative infinity now, because we're going to have 3 times some big negative number is just going to equal negative infinity. Remember that you can't get any bigger than infinity, so there's no point in saying negative 3 infinity or negative infinity cubed or anything like that. We just leave infinity as like the biggest number. It's boundless. It never ends. So that's it. So for as x approaches infinity, this limit would be infinity. As x approaches negative infinity, it would be negative infinity. So what you need to do is look at the highest degree term and pretty much cancel everything else out, and then plug in your infinity and see if it leads to positive or negative. And really, now we're going to get into rational functions. I want you to stay in the same mind. We're not going too far away from what we just did. So again, the first strategy, well, this is for a degree of denominator is greater than the degree of the numerator. Okay, so now what we can look at is we can see, well, we got x cubed on the bottom, we got 4x squared on the top, so yep, that's true. Degree of the denominator is bigger. And like we said earlier, when we said that when you have smaller degrees, when you're talking about infinity, the smaller degrees don't even matter. It's like they're not there. So pretty much what is happening when we take this limit as x approaches infinity is we're getting a decently big number up here. So say we could say it was like 1,000. Then what's happening at the bottom is, because we have x cubed, we're getting like some huge number. And that number is getting cubed every time, whereas this number is just getting squared. So it's getting closer and closer to being like 1 over some huge number. When we have 1 over some huge number, we know that that limit is 0. I'm sorry if that was like a confusing explanation, but in general, all you need to know is that the limit as x approaches positive or negative infinity when the degree of the denominator is greater than the degree of the numerator, f of x equals 0 every time. So if we were to take this limit as x approaches negative infinity, I'll show you what that would look like. It would be some big positive number up here because the x squared is positive, so we'd have some positive number here, say like 100 or something. Then on the bottom we'd be getting some humongous negative number. And as you can see, that's going to be like 0.001. It'd be negative 0.001, but it's still approaching 0. And that's what a limit is. It wants to know what is it approaching as it goes to negative infinity or infinity. So this one may equal like some super small positive number, but it's still approaching that 0. And this one's going to be some super small negative number, but it's still going to be approaching 0. So in either case, just know that if the denominator has a larger degree, it's going to be 0. Alright, so now let's think, okay, so what if the degrees of the denominator and numerator are equal? That's a unique case because, again, our strategy is always to just ignore all the other terms. So we're going to do that here. We're only going to focus on the highest degree terms for the numerator and the denominator, which in this case is both the cubed terms because there's no anything to the fourth or anything greater than that. So we've got pretty much 4x cubed divided by 9x cubed because we can ignore all the smaller degrees. And then what we can do is we can simply cancel out the x cubed. So the limit as x approaches infinity of that is just going to be 4 over 9. So all it is coefficient division. So we can say that. We can say limit as x approaches positive minus infinity when the degrees are equal, f of x equals coefficient of numerator of highest degree numerator divided by coefficient of highest degree denominator. It's that simple. So for this one, and it's the same thing with negative infinity, nothing's changed. We again would do the same process where we say limit as x approaches negative infinity, and then we would say, okay, well none of the other terms matter because they're too small in degree. And again we would cross out, and again we would be left with just that 4 over 9. So limit as x approaches negative infinity, f of x is 4 over 9. So this is the kind of formula for this one. Limit as x approaches positive or negative infinity, f of x equals, let me write an equals, coefficient of the highest degree numerator divided by coefficient of highest degree denominator. Alright, so now is when it gets a little bit tricky, is when the degree of the numerator is greater than the degree of the denominator. Because now is when signs start to matter. But again, same thing that we're going to do. We're going to take the highest degree of the numerator, highest degree of the denominator. I just wrote those backwards, but and then we're just going to focus on those. So we're going to say limit as x approaches infinity, and we're going to only pay attention to the highest degrees. Highest degree of the numerator is that x to the 5th. Highest degree of the denominator is that negative x cubed. And now what we want to do is we kind of want to simplify it as much as we can, see what we're left with. So we can take out an x cubed on the top, get x cubed and x squared divided by negative x cubed. Then we can cancel out the x cubes, and we'll get limit as x approaches infinity of x squared divided by negative 1, because we still have that negative sign there. So this would be the equivalent of negative x squared, so limit as x approaches infinity of negative x squared. So that would equal just negative infinity. So limit as x approaches infinity, f of x would be negative infinity. So what we need to do here is we need to, again, take out the highest degree term and then try to simplify it as much as we can, and then substitute in infinity and just try to see where it's going. In this case, it is negative infinity. And now let's try it with the when x is approaching negative infinity. So limit as x approaches negative infinity. Again, we're going to start with the same thing. We're going to only look at the highest degree terms. So we've got x to the 5th, negative x to the 3rd. Again, we're going to do some simplification. X cubed, x squared over negative x cubed. I can cancel these out. I'm left with limit as x approaches negative infinity of, I have x cubed divided by negative 1 which is the equivalent of negative x squared. And then I've got limit as x approaches infinity of negative x squared. Negative x squared. And yeah, so then if we take negative infinity, so negative infinity squared, we can see that negative infinity squared is going to give us a positive infinity inside of the exponent and parentheses, but then we still have this negative out front. So the limit as x approaches negative infinity would still be negative infinity. F of x equals negative infinity. Now, please notice that the limit as x approaches infinity and negative infinity do not always have to be the same. That just happened to be the case in this problem. What you need to do every time is test this out and see. So I hope this made sense. I hope you understand the three rules. As you see more and more problems with it, they'll come naturally to you, and you really just see, oh, it's a polynomial. I know it's going to be plus or minus infinity, and you can do a quick check. And then definitely try to remember these rules right here. If the denominator is a greater, then it's just going to be 0 for plus or minus infinity. If they're equal, coefficient division, just like that. And then if the degree of the numerator is greater, you got a little bit more work to do, but it's not too bad.